Hi, I'm Oliver, a PhD in machine learning and current solutions consultant here at Ataccama. Today, I'm going to be showing you how Ataccama and its suite of data quality tools can be used to let data scientists and machine learning engineers create better machine learning models more quickly. So to do this, let's look at a typical machine learning project in the healthcare industry who are already familiar with common machine learning tools such as Databricks, which we'll use for the sake of this demo. So here we have a big data set of test results from patients of various hospitals, and what's ultimately being asked of the data scientist is for them to use this data to determine patients at a heightened risk for a heart attack to allow for more optimal and streamlined treatment, as an example. And so if we look at this data, as a casual observer, we already see a lot of common data issues where we have variations in the sex column, we have lots of nulls, we have big variety in some information where perhaps a unit's changed, for example. And that's a big problem because, as anybody familiar with machine learning knows, one of the main principles of getting good performance out of a model is that garbage in results in garbage out. And what it means for our data scientist who actually has been asked to come up with this predictive model is that 50 to 80% of their time on this project isn't actually going to be making a predictive model. It's going to be doing what we've just done now, where we're being just given a table of information and ourselves in a silo determining what these data issues are and performing one-off, very manual cleanup, all of which has to be repeated inevitably the next time that this data gets used in another project. So how does that play out in Ataccama? Well, let's use our native connections to data and the processing and Databricks, and let's look at that exact same data set. But you'll immediately notice a difference, and that's that we've made data quality a team sport. So the data scientist who's been asked to come up with this model doesn't just get a dump of that data. They'll be told, oh, here's some machine learning predictions to say, well, maybe this data contains PII. And oh, these are the exact issues that are wrong with this data set. And because it's a team sport where everyone is contributing and we aren't making data scientists work in silos, we can even see non-obvious issues as well. So let's look at this seemingly perfectly fine record where we see, oh, here's an unreliable test machine. What does that mean? Well, we can open up the details. We can go to the data quality rule that's been applied. We can look at a description that tells us what's going on and see that, oh, between this little period of time, there was some incorrectly calibrated research equipment. So now, instead of having to spend 50 to 80% of this project just understanding and cleaning the data within a silo, all that happens is the data scientists, they go into the Ataccama data catalog, they get the data set, and they're given the additional issue tables that let them quickly filter and impute based on all the issues they're now already aware of. And the data engineers get a source of issues that they can remediate against, all of which is of course doable within Ataccama and one tables. And that means that when the dataset is used again in another project because we want to reuse our data to solve multiple problems with it, it's fixed for everybody. So let's revisit this concept again of garbage in and garbage out and look at how a machine learning model performs against an evaluation dataset of known, good, clean data after it's been through the Ataccama process, where Ataccama is telling us we have great data quality. This is what we want to be testing our machine learning model against. We don't want to test it against garbage. So let's go back to Databricks and look at the performance of our model now that we quickly dealt with all this bad data. And what we see is that we get a better performance baseline on a bunch of reasonable standard usage statistics where we're saying the precision is better, the accuracy is better, the F1 score is better. Every conceivable statistic that we want to use to build our model just by using clean data is better. We're starting to build our model with a better baseline, and we get more time to actually work on the model to make it better on top of that. But what's really good is that even after we finished and developed our model, Ataccama can still be incredibly helpful. In a business context, we need to think about how we continuously evaluate that model in a production environment to make sure it's still working and guard against data drift. So how would that play out without Ataccama, following standard DevOps practices used today? So let's say we finished our model and the MLOps team came up with a way to evaluate it against known clean data sets over time. And what we'll see is, oh, look, the model's working, it's working, it's working, it's working, it's working. Oh no, it's suddenly not working. But using standard MLOps tools, we're going after the fact. We're just going off the outcome. We just know, all we know is the output isn't correct. We don't know what has gone wrong and we don't know what is incorrect. So let's go back to Ataccama again. And here we're using Ataccama's data observability module that allows us to monitor data as it changes proactively against many, many things, from just the pure data quality to machine learning powered anomaly detection on both the data and the metadata, to schema changes, to the business terms changing, to the structure changing, and even how fresh the data is relative to itself and how often it's used to changing. And we're immediately starting to see a couple of issues. So one, the metadata anomaly detection has noticed a change, and two, the schema of the data itself has changed. So let's open that data set. And oh, there we go. We have a bunch of issues in the gender column. Let's open it and we can see, oh, we're violating this gender synonym rule that we talked about earlier. We can even look at it, see the description, and see that it should be male or female. And just like that, we've immediately found what the issue is. The data has changed, there's been data drift, and the machine learning model is now seeing new data and classifying it incorrectly. And in just seconds, we've got a root cause. Ataccama and the data catalog has given us a data owner to take responsibility for fixing it. And we now have a path to fix this problem very, very quickly. So, sum up. If you're building machine learning models, don't do it in silos. Ataccama is a great tool for breaking down data silos and make data quality and governance a team sport where everybody contributes. You can make better machine learning models, you can make them faster, and you can make them more trustable in production too.